Dear colleagues, my name is Oleg Sichev. I am an associate professor of Volgograd State Technical University. Today I will tell you about our experience in using regular expressions as templates for open-answer programming questions requiring writing a single line of code. Those questions proved useful in our introductory programming course. My talk will be organized as follows. First, I'll give a short introduction into line writing questions, their role in introductory programming courses, and different approaches to their implementation. Second, I'll talk about features of PEREC software that we developed. This will be followed by the results of 4 years of using regular expression questions in our course Programming Basics and discussion of those results. Introductory programming courses are considered hard both for teachers and students. They develop intellectual skills in new areas on many levels of Bloom's taxonomy of educational objectives, from knowledge on new concepts to synthesizing programs and evaluating programs written by others. According to Bloom, developing high-level skills requiring good mastery of lower-level skills. Without this support, low-performing students can become stuck trying to solve a complex task without good mastery of their subtasks. Writing a line of code is a task at the application level of Bloom's taxonomy, requiring students to apply syntax and semantic rules of the programming language they study. This provides adequate scaffolding to analyzing and writing programs by developing underlying skills to be automatic. There are several ways to implement programming tasks. We can insert the student line into a template program, compile it, and test it. We can compare parsed trees of the student's answer as the correct answer, or we can use a string template to match all the correct answers. Compiling and testing approach naturally takes into account all different ways of solving the task correctly, but it has low error tolerance, providing compiler messages that can be poorly understood by novice programmers, low quality feedback, showing the results of the whole program where the student's task is writing one line, and requires a lot of effort to create a template program and a set of tests for each one-line question. Comparing syntax trees is a good way to take into account syntax variability without writing tests. However, it handles semantic variability, different ways of iterating the same results, poorly because it requires listing all the variants. For example, in the C++ programming language, there are 6 ways of incrementing a variable. This is especially bad if the answer has several independent variable paths, because the number of possible correct answers rises multiplicatively. 3 paths with 3 variants each give 27 variants of answer, and there are worse cases among lines of program code. This limits the task that can be practically given to rather simple lines. Error correcting paths can give meaningful, detailed feedback, but their big disadvantage is that they can only handle a few errors at once. When the student's answer is too wrong, no meaningful feedback is possible, which is bad for introductory programming courses when the error severity isn't limited. Using pattern matching for the line of code allows taking into account both syntax and semantic variability with moderate amount of effort. If the answer has several variable paths, they are entered separately, so the number of variants is additive, not multiplicative. The options at providing hints are limited with string completion hints, showing the first wrong character and correct ways to continue the answer after the wrong character. But they allow the student to complete the exercise and find the correct answer without teacher's help. Pattern matching has highest fault tolerance because it can show the student a way to the correct answer regardless of the number of errors in the original answer. We consider pattern matching a good way to implement educational tasks requiring writing a single line of code because of its high fault tolerance and medium effort required to create question banks. One of the downsides is the necessity to learn pattern matching syntax for question authors. Fortunately, there is a way to write string patterns that is well known in software engineering, regular expressions or shortly regexes. They can deal with some sort of syntax variability well. Some dialects provide advanced features necessary for handling lines of code. Because of deficiencies in existing regular expression-based questions, we at Software Engineering Department of Volgograd State Technical University developed a new model of regex-based question for Moodle Learning Management System. Our model is called PEREG, from Basic Pattern Matching Functions in the PHP language. PEREG allows using the most developed regular expression dialect, Perl-compatible regular expressions, formatting students' responses to teaching-defined templates. One question can contain several regexes, each with its own grade and teacher-defining feedback. PEREG software can determine partial matches and so show partially correct responses, marking correct and incorrect paths in green and red colors respectively. It can also generate the shortest completion of a partial match, which allows hinting next correct character and next correct token. Regular expressions have many features that are good for matching lines of code. For example, combining the character class for whitespace characters with infinite quantifiers, we can deal with optional and required spaces which aren't limited in real program. Using parentheses around sets of alternatives can make them independent and significantly reduce the amount of work if there are several independent groups of alternatives in the answer. Character classes can be used to allow any number or identifier, while back references let to remember this identifier and require exactly it in a different place. Finally, recursive subpatterns are a unique feature of Perl-compatible regexes that allows solving the problem of extra parentheses. But you can see that the system for dealing with extra parentheses is very complex. It would have made expressions with several possible places for parentheses unreadable. To deal with this problem, in PEREG software we developed our own syntax, which is based on regular expression comments available in the extended notation of Perl-compatible regular expressions, so that it doesn't interfere with the way regular expressions work. It simplified dealing with extra parentheses considerably. Regular expressions for lines of code might look complex, but they are usually constructed in stages using simple algorithms, as you can see on this slide. First, the special characters in the original lines of code are escaped. Then those lines are merged into as few expressions as reasonable to use partial alternatives. Then sub-expressions for extra white space characters are added routinely. The final touch is accounting for extra parentheses. In extended notation, line breaks and leading white spaces can be used freely to format the expression and improve its readability. This process looks more complex than when it's actually done. Many stages can be automated, but our team of question authors didn't feel the need to do it even when creating more than 1,000 of regular expressions. PEREG software has advanced features for developing and testing regular expressions. Some of them can be seen on this slide. Question authors can enter any number of possible answers and see how they match their expressions. For partial matches, the system shows the wrong part in red. Two of the tests on this slide are failed because of wrong parentheses. Notice the icons that show if the string matches the expression fully. A green string can be a partial match if it's too short. The tests are automatically saved with the questions and can be used later, for example when improving regular expressions. When students make errors, PEREG module shows them partial matches the same way they are shown during testing, with green and red parts of the string. If the teacher allows hinting, students who give a partially correct answer can ask the PEREG module for the next correct character or next correct token. The hinted parts are shown in yellow color. In this slide, the student already asked for the next correct token hint, so its button is hidden. You can see the buttons for the next correct character hint and verifying the updated response. This experience report sums up 4 years of using regular expression questions in an introductory programmer course at Volgograd State Technical University. The data we gathered during the course Programming Basics that is taught in the spring semester of the first year to the students majoring in software engineering and computer science. We gathered the data from 479 students. The counts of students each year were comparable. The course contained quizzes which used regular expression questions among other questions. from 1 to 5 PEREC questions per topic quiz consisting of 10 questions. Our team developed a question bank of 722 PEREC questions containing 1160 regular expressions. The course had 6 major topics with laboratory assignments requiring writing a program. Each topic had a summative quiz that students should pass before doing the programming assignment to verify that the students have necessary basic skills to attempt it. The passing grade was 60%. To prepare for the summative quiz, the students were given 3 kinds of formative quizzes: regular quizzes with the most complex questions, and 2 kinds of open answer quizzes with hints, PEREC and correct writing. So PEREC questions with hints were a part of a bigger system for preparation to formative exercise. In summative exercise, PEREC questions were used to grade students' responses. As a part of the final exam, the student had to pass the exam quiz that used the same question bank as the summative quizzes, but contained questions concerning the material from the entry course. They could use the same formative quizzes to prepare for the exam quiz. The students who performed exceptionally well during summative topic quizzes, passing 4 out of 6 quizzes with at least 80% score, were freed from the exam quiz. The formative quizzes were voluntary and intended to be done during homework. They did not affect the course grade. The allowed attempted to answer the same question until the answer is correct and using hints. The summative and exam quizzes were taken during classwork. They affected the students' grade and allowed only one attempt to answer each question. The students who failed a summative quiz could reattempt it later as a whole. This motivated students to use the formative quizzes to prepare. The first part of our study concerned studying the regular expressions used and answers at them. Most of the regular expressions have low numbers of alternative variants, the mean in less than 2, but some had up to 18 significantly different ways to answer them, not counting white spaces and other minor changes. The questions verified using regular expressions had answers about 14 tokens and 31 characters on average, up to 70 tokens and 109 characters. Most of the expressions matched from 1 to 6 uniquely studied answers, but some matched more, up to 29 uniquely answered matched by 1 regular expressions when ignoring difference in white spaces and other minor difference. This shows that regular expressions allowed significant variety among the answers, but most of the questions required only a limited amount of it. The most severe problem when introducing regular expressions for matching program code was extra parentheses in expressions. We introduced subpattern matching and special syntax in our matching engine and updated the regular expressions, which increased recall and depth measure, as you can see on this slide. The results are impressive given the diverse nature of the answers on line of code questions. The remaining few false negatives were easily dealt with by teachers manually. To understand the numbers on this slide, you should keep in mind that one quiz attempt creates several question attempts. As you can see, most of the students who attempted formative quizzes and could use the hints found correct answers to at least some of the questions without asking teacher. Answering only some questions was a valid tactic to use a formative quizzes because you receive all kinds of questions about the given topic when you start a quiz attempt. Less than 3% of students attempted to answer questions but didn't find any correct answer. On the question level, almost 80% of the attempts resulted in a correct answer. About 1/3 of them used hints. In 7% of attempts, students didn't try to answer questions at all. They simply hit finish the quiz button to read the teacher-defined feedback. However, in more than 10% of the attempts, students didn't reach the correct answer even having access to hints that will eventually lead to them. And 1/3 of those students tried to use the hints. Generally, only about half of the students used PEREC formative quizzes voluntarily. Others preferred regular and correct writing formative quizzes that the teachers thought unethical to block to study the effects of PEREC. The students who used pre-quizzes made about 9 attempts of 6 quizzes on average. This plot shows the average exam score grades depending on the percentage of formative quiz attempts that used hints. It has a peak around using hints in 40% of the attempts. Both students who didn't use the hints at all and those who used them often performed worse at the final exam than the student who used hints sparingly. In this slide, you can see two examples of students' usage of pre-questions for training. The most important is the left example, which starts very far from the correct answer, farther than the ability of most correct grammars to make sense out of it. Still, after 9 tries and using 8 different hints, the student was able to find the correct answer and learn from it, and it took only 4 minutes. This supports the hypothesis that pattern matching questions with hinting can help students to find the correct answer regardless of the number of errors they make. So, what can we learn from this experience? First, it was possible to create regular expressions matching single lines of code for the task the teacher wanted to use in an introductory programming course. Most of the expressions had little variability, but some allowed many answers. This let us deal with high variability in the students' answers while providing a note feedback to the students regardless of the number of errors they made. The authors created more than 1,000 regular expressions to match program code. The process was straightforward and they didn't feel the need to automate it. The most common problems when using regular expression matching for answers containing program code is extra parentheses in expressions that can be dealt with by using recursive subpattern. This allowed us to achieve great precision and very good recall. The few remaining cases of wrong grading were dealt with by teachers manually. Most of the time, students were able to find the correct answers to the formative questions without using teachers' help. Some of those attempts started from very wrong code, which would have prevented meaningful feedback by other methods of automated grading of program code. About 1/3 of the attempts used hints. The chief benefit of introducing pre-questions was significantly reducing time the teaching staff spent on answering students' questions about their formative quizzes. About 500 of formative questions per semester were answered correctly using hints. In other circumstances, they would have led to students asking questions to teaching staff. There was no significant link between using formative quizzes and exam quiz results, which is understandable because students had access to two other kinds of formative quizzes and questions comprise only about 1/3 of the exam quiz. But there was a weak link between using hints sparingly and better performance during the exam quiz, which can show best learning practice. String completion hints show how to fix the answer, which helped greatly foreign exchange students who had troubles understanding teachers and textbooks. They were also a great help during COVID lockdowns when interactions between student and teaching staff were problematic. So, our conclusion is that regular expression matching is a viable way to implement line of code equations that fill important gap in developing programming skills, letting novice programmer master writing code gradually. Supplementing pattern matching with string completion hints significantly reducing the time that teaching staff spent answering students' questions about their practice quizzes, saving classroom time for more complex work. The developed tool per question type is available under GPL license in Moodle plugin database. We will be glad to receive feedback about using it in your courses. Thank you for your attention.